Hi, this is Forerunners. Today we have Kai, Keying, Qianxue, and Xinru. We will present our lessons learned from the pilot project. First, let's review our three expectations for the NMT. For efficiency, the PEMT should be approximately 50 faster than human translation. For cost, the PEMT should be 40% less than human translation. And for quality, NMTs are expected to register no more than 15 error points per 1,000 words. According to this chart, we can see that after months of training, we find that Microsoft NMT only met the goal of efficiency. The other two are far from satisfactory. In addition, System also failed the goal of quality, even much worse than Microsoft. There are records of blue scores for each round on Microsoft. We did some changes to the dataset every round, such as creating a dictionary or adding more data to training and tuning. We also trained System with the same dataset to the best score module on Microsoft. We can see that their blue scores are so close, even with totally different quality performances. Next, Qianxue, please.
Thank you. I will talk about the quality assessment. We used a multi-dimensional quality metrics model for our quality assessment. And as Kai mentioned, we could not meet our quality goal. And in total, we conducted 2 rounds of quality assessment. And the first one was based on our model 1, and the total error points was 130. And the last round, the second round we conducted was based on the model number 5, and the total error point was 121. So you see there's a drop in the total error points. However, if you see closely on the table on the right side, the number of critical errors actually increased. So even though our blue score has been increasing through the training, we realized that the quality of the translation cannot be guaranteed. And through our evaluation, there are 2 types of errors that we sent out the most in this machine translation, which is tense confusion and a lack of clarification. We found a great example to demonstrate both, and it's as shown on the slide. We compared the machine translation from model 5 to the human translation, which we used as a reference in our training. First, as you can see in the orange part, the tense in the MT is incorrect. We think that this is because tense indicators in a Chinese sentence tend to be unclear, and the machine is not yet well trained enough to determine the tense based on the nuanced context. Also, as you can see the green part, the 3 critical battles part definitely needs further explanation for the English-speaking audience. The government work report contains a number of China-specific concepts and terms, and its concise nature also makes it even more challenging to run a machine translation. So even though we added substantial dictionary data to train the machine, it was not enough for the machine to have a translator mindset to think about the readability from the perspective of the audience. Next, Keying, please.
Okay, we did some changes in the project timeline. We used to plan to spend 1 week on the first round of training and human evaluation. But unexpectedly, due to difficulties we ran during the data alignment, we actually spent 2 weeks on this part. And in the following week, we did the rest of 4 rounds of training. We also spent some time on a comparison with System, another system, in order to better understand which system does better in MT. So the overall timeline actually was extended to April 10th, a week later than it should used to be. Next, please.
I'd like to talk about our project costs. The cost of the whole machine translation engine training project is $4,334. And most of our money are spent on meetings, including check-ins, client meetings, proposal updates, lessons learned preparation. We spent a total 50 hours in our meetings. And we also spent 32 hours doing the data preparation, which is basically data alignment. I'd like to move on to the next slide. So we didn't meet our cost of post-editing machine translation goal. The pricing goal should be at most $1,500. However, the total cost of post-editing machine translation for this project is $5,134, which is much higher than the cost of human translation. Next.
So as Colleen mentioned, we compared a Microsoft custom translator with the Systron to see which one can produce a better translation. And it is based on the Microsoft model number 5. So we put the same training and tuning data in the Systron system and used the generic L parent model to train. The baseline BLEU score we had is 19.5, and the result is 28.78, which is an increase of 10.28. And the total error points of the Systron output is 219. So it's definitely not a very preferable outcome. Next, Sinru, please.
Thank you. So what went well during our whole project? First of all, we had excellent teamwork. Everybody on our team is responsible, and we always check in on time. Second, with the quality translation memory, that is TMX files, saved a lot of time of data collection and data cleaning. Third, compared with the baseline, our BLEU scores went up steadily. Next slide. However, we faced a lot of challenges during the whole project. First of all, our training data either exceeded the 2 million character limit or failed to meet the 10,000 segment requirement. This is because our training data includes a lot of lengthy segments. Second, this leads us to our second challenge. We spent a lot of unexpected time to compile and realign training and tuning data. Third, we also encountered some challenges when we're dealing with the file management. It actually slowed down our process of data alignment because only one of us have access to online TMX file generating website. Next.
So why didn't the NMT engine work? Our team has concluded several reasons. The first one being inadequate training rounds due to the character limits and the segments requirements. We only trained 5 rounds in Microsoft Custom Translator, and it is not enough to fully train an NMT engine. And the second reason that we conclude is about content. The text type we chose contains many China-specific concepts and terms. Human translators can make explanations, but NMT engine just can't. And the third reason is about style. The languages are less controlled, meaning that the structures of the text are more flexible than the NMT engine can expect. And the long source sentences also create some challenges to it. We learned in class that NMT is better at translating shorter segments, and that's definitely another reason. Next slide, please. So as for opportunities to improve in the future, if the client wishes to improve the system in the future, we have listed several steps that could be taken. First, more text specific to the topic added to the training data set. The majority of our documents are government work reports in the previous years, and we've seen good results from it. But such an amount is not enough. We need to put more data into the training data set in order to achieve better results. And the second step we could take is to have shorter segments in both training and tuning data sets and have standards for alignment. During the training, we have already cut short segments, but they are still too long for an NMT engine. In addition, everyone did alignment with their own preferences. So we suggest that if you are going to improve the system in the future, you could have shorter segments with standards for alignment. And the third step is to add more aligned text to the tuning data set. The Model 5 has shown to us that more and better tuning data can improve the BLUE scores. So definitely adding more aligned data to the tuning data set. But before you take actions, please think twice. The cost savings already failed to meet the goal, and the MT output is far from satisfactory. And don't forget that we used the free accounts to this pilot project, meaning that if you want to continue to use Microsoft system, you need to pay the subscription fee to its services. Next slide.
Finally, let's move on to the conclusion. We do not recommend training a neural machine translation engine for Chinese government work reports from Chinese to English. So that's all our lessons learned. Thanks for your listening.